Hello, this is Scholar Strife doing some math. Today in geometry 0.2, still in that unit 0. Um, we'll be reviewing over radicals, simplifying radicals. So a perfect square is the product of a rational number multiplied by itself. As in, I take a number, multiply it by itself. That is 9. 9 is a perfect square. 25 is a perfect square. Perfect squares. Like radicals. So let's say we have a radical, square root of 3, and let's have another one, 2 square roots of 3. So what makes them like radicals? Like radicals is that they have the same square root. So they have a square root of 3 here. These have 2 square roots of 3 here. They are the same radicand. So an example of not like radicals. So not like radicals. 3 square roots of 5 and 3 square roots of 2. Okay? They don't have the same square root. They are not like radicals. So properties of radicals, if we multiply them together, so if we have square root of 2 times square root of 3, we just put them together under one radical, square root of 2 times 3, which is 6. Same thing with division. We can separate them into 2 separate radicals. So if I have square root of 3 over 7, that's the same thing as the square root of 3 over the square root of 7. And you can work backwards as well, which means if I started off with this, I could end up with this. When we're multiplying radicals together, we want to take the outside numbers and multiply the outside. Take the inside numbers, multiply the inside. So I'll do that example later on. Rationalizing the denominator. So we do not like having square roots in the denominator, and I'll show you how to get rid of that in a bit. And we can only add like radicals together, and I'll show you more during the examples. So simplest radical form, square root of 18. So we want to simplify it. So we want to break it down into its most simplest form. So one way to do it is we're looking at 18. And we're going to look at factors that make 18. So 2 numbers that multiply together. So easy one is 9 and 2. And we can stop there because we reached a perfect square, which is 9, and we're left with just 2 on the inside. So what will happen is, so we have square root of 9 times the square root of 2. So I broke it apart. Square root of 9 is 3. And then we have square root of 2 left over. Now one thing you might want to write down is the list of perfect squares. So we have 2 squared, which is 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81. And so on and so forth. So remember these numbers in the right column are your perfect squares. So this is my answer here. So let's do another one. 54. So 54. I always like to use, like if I don't know a perfect square right on the top of my head, I like to divide the thing by 2. So I have 27 and 2. 2 can't be broken down. Well, it'd be broken down into 1 and 2, but that doesn't do anything. 9 and 3. So notice, and I'm just going to break it further just in case I didn't know 9 is a perfect square. So what I'm doing is I'm taking a pair here, pair of 3, and one way to look at it is this. So square root of 3 times square root of 3 times square root of 3 times square root of 2. So I'm taking all my outside numbers here. So these two become square root of 9 times square root of 3 times square root of 2. So we know that the square root of 9 is 3. And then square root of 3 times square root of 2 is the square root of 6. So 3 square roots of 6. So what we're doing here is making a factor tree. That's what this is. This is a factor tree. And if that helps you, do it that way. Otherwise, memorize all these perfect squares. Okay. So notice in the factor tree, I only took the outside numbers, the branches here. So here, here, and these two bottom numbers. I didn't take the 27 because the 27 was broken down into 9 and 3. This 9 was broken down into 3 and 3. Okay. Let's do some more. 3 square roots of 2. So here we're going to rationalize the denominator. We do not like having square roots in the denominator. So what we're going to do is multiply both the top and bottom by whatever that square root is. So we have square root of 2 in the bottom, so I'm going to multiply top and bottom by square root of 2. So this becomes on top 3 square roots of 2. And then on the bottom, square root of 2 times square root of 2 is square root of 4. But what does square root of 4 equal to? And then that's our answer. 10 divided by the square root of 5. So I'm going to multiply both top and bottom by square root of 5. So I'll get 10 root 5 here. And then on the bottom, I get square root of 25, which is 5. But I'm not done yet because I have 10 times the square root of 5 up top, and then we're dividing by 5. These can be reduced. So 5 goes into 10 2 times, and then we still have that square root of 5 left over. But on the bottom, it can become 1. So your answer is 2 square roots of 5. So this one is a little bit tricky because they start off with one fraction in a square root, but remember we can split them into 2 square roots. Okay, we don't like having the bottom one, so we multiply top and bottom by that. Square root of 2 times square root of 3 is square root of 6. On the bottom is square root of 9. And remember, square root of 9 is 3. This is square root of 5 over square root of 7. Multiply top and bottom by square root of 7. So I get 5 times 7, which is 35, but that's under a square root. And then we have square root of 49, which is 7. All right, so we can combine like radicals. So remember, like radicals is just like example 4. Think of it as 2 square roots of 3 plus another square root of 3. So that is 3 square roots of 3. Well, another way to look at it as in 2 apples plus 1 apple equals 3 apples. 6 apples plus 3 apples is 9 apples. 4 square roots of 5 plus square root of 2 plus 7 square roots of 5. So square root of 2 is not like the others, but the other two are like them. So 4 square roots of 5 plus 7 square roots of 5 is 11 square roots of 5. And then we just add the leftover square root of 2. That's it. That's all we can do. Here, 4 square roots of 2 plus 1 square roots of 2 is 5 square roots of 2. And then we have that square root of 11 left over. Okay, sometimes we have to simplify them first, break it down. So square root of 27 becomes 9 and 3. So this becomes 3 and 3. That's a pair, so that's coming out. And what's staying inside is this leftover 3. So let me rewrite that. Square root of 3 plus 2 square roots of 2 plus 3 square roots of 3. 4 square roots of 3 plus 2 square roots of 2. And that is our answer. Lastly, 90. Oh, okay. So we have to break this down quite a bit. So I'm just going to look at the first number. This one first. Square root of 8 can be broken down into 4 and 2. So I'm just looking at 8, breaking down into 4 and 2. Okay. So 5 times the square root of 4 times the square root of 2. Square root of 4 is 2, so 5 times 2 times the square root of 2. So this becomes 10 square roots of 2. Okay. 98 becomes 49 and 2. And we know that the square root of 49 is 2. So square root of 49 times square root of 2. And don't forget that plus sign. There's a plus sign there. 7 square roots of 2. And then 18 breaks down into 9 and 2. So we have minus 2 times the square root of 9 times the square root of 2. So that would be minus 2 times 3 times the square root of 2. So this would be minus 6 root 2. So we have 10 apples plus 7 apples minus 6 apples. So 17 minus 6 square roots of 2. So 17 square roots of 2 minus 6 square roots of 2 is 11 square roots of 2. Hopefully that wasn't too confusing for you. Hopefully you've seen square roots before. I kind of rushed a little bit through the tree, but it's something that you should have worked on in your algebra class. If you haven't, we'll go over it during our Zoom session. Work on the homework. Have a good day.